Hi, everyone. Welcome to this installment of the lecture series. I'm Aria. I'm the director of the Science Squad. And today we're bringing two new people to you guys. First, our newest member of the team, Emma Oswald, and she'll be introducing herself in a moment. And today's lecture features Dr. Dave Pawlowski from Eastern Michigan University. And he'll be talking a little bit about the field of astrophysics and how you can be part of it. I'll turn it over to Emma to introduce herself right now.
Awesome. So hi, my name is Emma Oswald. I'm the newest intern at the Science Squad, and I'm very happy to be a part of this. I live in Mount Pleasant, Michigan, and I grew up here, and it's really nice, and I'm really excited. So without further ado, Mr. Dave Pawlowski from Eastern Michigan University.
Okay. Thank you for the introduction, Emma. I'm Dave Pawlowski from Eastern Michigan University, and I'm broadcasting from the beautiful Ann Arbor Library downtown. I was asked to talk a little bit about my field of astrophysics, planetary science, and that sort of thing. And I am at heart, I guess if you ask me what I do for a living, consider myself to be a space physicist or a planetary scientist. And these things, they're just names. You can call me a physicist or an astronomer, or astrophysicist. They're all the same thing. But what I do spend most of my time on is studying the atmospheres of Earth and Mars, actually like space at Earth and Mars, although we are a bit pedantic and we call them atmospheres. And so what I want to do to talk about today was the kind of a question I've been thinking a lot about lately, and it has its roots in space exploration. And so the question that I want to kind of like think about is this question of like, okay, we're going to go to Mars. What do you have to pack? It's a big question. It's a really important question. Mars is a long way away, and there's some challenges to getting there. So, knowing what you're going to bring along for the trip, I think it's pretty important. And I'm not talking about like scientific equipment or anything like that. I'm just talking about like personal stuff that you should have on the trip because you want to enjoy yourself. But, I think if we're going to talk about what we're going to bring to Mars, what we're going to pack for Mars, then we kind of have to put some contextualize it a little bit. And I think you have to ask the question, well, wait a second, Dr. Pawlowski, why am I going to Mars? Like, why would I even do that? It's a crazy, crazy talk. I should stay here on Earth where it's comfortable. But I think there are reasons to go to Mars or a different planet. There's a lot of talk lately about like, we need a backup planet in case something happens to Earth. Yeah, maybe that's valid. I don't particularly buy into that line of reasoning. I think there are other reasons to go to a different planet. And I think one of the better reasons is, well, as a species, as a human species, we have always been really good at exploring. And it sort of seems logical to think that eventually we are going to explore out into the solar system and go check out another planet. So I guess another follow-up question to that one would be, well, why would we go to Mars? Why not go somewhere else? Like the moon, it's a lot closer. I can see it right there in the night sky. Why don't we go there? And I think there are really good reasons to go to Mars. And I don't want to get bogged down in them, but I would name a couple. Like, for instance, the moon. A lot of people think we should go to the moon. I don't know. The moon's nice. It's really pretty at night. I don't know. Like, personally, I like daylight. I like to go outside during the day and it's bright out and I don't feel like I should be sleeping. You don't get that on the moon. The moon doesn't have a very thick atmosphere. I mean, it barely has any atmosphere at all. So what that means is, yeah, when the sun's up in the sky, it doesn't really interact with an atmosphere. And so it's, it's dark. You see the sun, but there is no atmosphere. So it's dark. That's kind of boring. The other reasons are, like the moon doesn't have an atmosphere, so it doesn't actually protect us very well from high energy particles that are zipping around all over space. And those particles can really be damaging to our bodies. It can cause cancer and things like that. And that's kind of bad. I'd like to avoid that. So, other options for space exploration, we could go to Venus. Venus is the closest planet to us. It's towards the sun instead of Mars, which is away from the sun. A lot of people think we should go to Venus and like hang out in the clouds and like have balloons and things like that because, well, you may know that Venus's atmosphere is really, really hot and really, really dense and thick, such that like we've sent some robots to the surface of Venus and they died like in a minute. Just too much pressure. The pressure at the surface of Venus is 100 times higher than it is here on Earth, and the temperature is 900 degrees Fahrenheit or so. Not really great for living, in my point of view. So we could go past Mars. We can go out to the gas giants, but I don't know. I mean, they're really pretty, but the atmospheres are extremely dynamic. They're really kind of hazardous just from like a storm perspective. They kick up lots of winds, and there's a lot of energy that you'd have to deal with. And at the same time, they're really far away. I mean, sunlight, by the time it gets out to Jupiter or Saturn, it's really weak, and that makes it harder to grow things or power solar cells or things like that. And so I think that really Mars is the best option. I mean, it's relatively close. It's not too far away. It's not out to Jupiter. It's only about half as far past the Earth as the Earth is from the sun. So it's not too bad. You get some good sunlight out there. I mean, it's not too hot. It's not too sunny, but at least you get some sunlight, so you can power your equipment. The temperature is, it's doable. It's in a range where it's doable. The pressure is doable. It's not, it's not Florida on a nice sunny day, but it's okay. I think there's lots of scenery. There's lots of good topology and geographical features, lots of nice canyons and cliffs and sand dunes and things that are really pretty. No trees or anything like that, but, we can't be too picky. You may have heard a lot of the talk in the news recently about liquid water. We really think we've found some good sources of liquid water on Mars. And even if it's not liquid, we definitely know that there's water ice that is subsurface that we could potentially get to just by drilling down, and we can extract that and turn it into liquid water. And then, Mars, we haven't found life on Mars, but we haven't been looking really hard or really long either. So that's kind of interesting. Maybe if we send some humans to Mars, we can dig around a little bit, and maybe we might find some interesting life forms. So I think Mars is the place to go. So if you decide on going to Mars, I think the question is, well, how do we get there? And I think there's some interesting topics to discuss with, in regards to the trip. Really, this comes down to hey, Mars is pretty close. It's not too far away. It's our second nearest neighbor. But that doesn't mean it's close. It's not, right next door. So you got to take a rocket to get there, and it's going to take you a little bit of time to make that trip. Interestingly enough, I think a lot of people have a misconception about how rockets work. If you want to go to Mars from Earth, it's not just like a point at Mars and shoot sort of thing. I've got a kind of really nice professional picture here. Here's Earth, here's Mars. This is not how you do it. That's not going to work. If you point your rocket straight at Mars when it's sitting right here, well, by the time the rocket gets here, it's actually not going to be there anymore. I can actually show you an animation of this. This is a real problem, something that we kind of have to plan ahead for. And of course, scientists and astronomers do that sort of thing, and rocket scientists do this sort of thing. But what you see here is a video of basically a rocket being launched from Earth going to Mars at the wrong time. And what you should notice, as this kind of loops over and over again, is if you time it wrong, in this case, we launched that rocket a little bit too late. By the time the spacecraft gets there, Mars is gone. And so there's a lot of timing that comes into planning your mission. And that can be a little bit tricky. But we know the science behind that, we know the engineering behind that, we can do it. What it all comes down to, though, is if you're going on this trip to Mars, it's not going to be real quick. It's going to take you some time. And in fact, the average length of time that it might take you to get from Earth to Mars, today, if we tried to go, is somewhere between 6 and 9 months, depending on how much fuel you want to bring, how heavy your rocket is, and that sort of thing. So you can plan on a good 6-month-long journey just to get there. And then once you get there, because you can't just launch back and forth at any time, just like that video kind of showed, you have to wait for the timing to be right. You have to wait for Earth and Mars to be in the right positions relative to each other around the sun. So once you get to Mars, you can't just turn around and come back. It's not like a 2-week vacation. You got to wait a little bit. In fact, you probably have to wait about a year. So you get 6 months to get to Mars. You hang out for about a year. Then things align themselves just right again, and you take another 6-month trip back, give or take. So you're looking at about 2 to 2.5 years full round trip to Mars, assuming you want to come back and see your family and all that good stuff. All right, so it's a long journey. And in that long journey, well, there's not a lot of room in your spacecraft. There's not really good internet, small space, bad internet doesn't sound super comfortable. And a lot of the space that is in the rocket is taken up, by necessities toilets and computers to make the rocket run and all that stuff. So you have a very limited amount of personal space, which makes planning for a trip like that a little bit complicated. Before I kind of get into the details of what I would bring, it's really important stuff. What happens when you get there? Now you're on Mars for a year. and you're going to hang out for a while, what's it going to be like? Well, yeah, compared to other planets, the climate on Mars is pretty lovely. But compared to what we humans are used to dealing with, not so great. You may have heard that, Mars at the equator, when Mars is closest to the sun, you're at the equator, you're getting lots of good sunlight. It's beautiful outside. It's a nice 60 to 70 degrees Fahrenheit, give or take. The problem is Mars doesn't have, as I said, much of an atmosphere. It's about 1/100th as thick as Earth's atmosphere down here on the surface. What that means is all that heat can't stick around. When daylight goes away and you happen to be at nighttime, the temperature goes from a nice 60 degrees down to like -100 or so, which isn't so nice. So you probably have to bring a pretty good blanket. Also, that thin atmosphere, yeah, it does an okay job of protecting you from those high energy particles I talked about earlier, like on the moon, but it's not perfect. And so you're gonna have to protect yourself from that radiation that's going to be coming in through the atmosphere and trying to, basically kill you. It's a kind of an interesting fact that we kind of know how to deal with some of this. For example, astronauts on the International Space Station, they experience radiation more than you do on the surface because they're up high in the atmosphere out in space. But the amount of atmosphere that you get on the surface of Mars is about twice that what the astronauts on the space station get. So it's a little bit more of a risk just going to hang out on the surface of Mars. So what all this means is that probably at Mars, well, definitely at Mars, we're going to be an inside species. Probably going to have to live in domes that are isolated from the environment, maintaining a constant temperature, pressure, composition so that we can breathe. You're going to have some shielding to protect you from that radiation. You're going to have access to water. Maybe we can produce our own water. Maybe we can find it, mine it from underground or something like that. But you're not going to be able to take those nice 10-minute showers like you do here on Earth, or 20-minute showers. I don't know, whatever you do. There's going to be a lot of recycling of water, which means that water that gets flushed down the toilet, yeah, that's going to come back around again, and you're going to use that to drink and make your food and that sort of thing. Communication's a little bit of a problem. Earth is about, at closest, 4 light minutes to Earth. That means the amount of time it takes light to travel from Mars to Earth is 4 minutes. So if you're having a conversation with, your boyfriend or girlfriend or kid or mom, it takes 8 minutes for the round trip signal to go back and forth. But that's only when Mars and Earth are closest. When Earth is on the other side of the sun, that's a 40-minute round trip conversation, which is really not ideal. So there's some challenges. So I think that goes into this thought, well, what do we pack? So I don't know, you're asking me, I think I've got some idea of what I would pack to make this trip. I'm planning for, I think the biggest challenge for me is going to be sitting in the spacecraft. 6 months, confined area, a couple other people that I may or may not get along with really well. I got to have some things to go to make sure that I'm going to be in my happy place. So the first thing I'm doing in 6 months, I'm going to get a lot of reading done. And so I'm definitely bringing a couple good books. You may have heard of The Martian. It's a popular one. That way I'm going to be reminded, if you've ever read it, constantly about all the ways that Mars is going to try to kill me when I get there. I think that's really important to review and make sure you have a good handle on. I also personally like the Discworld series, Discworld by Terry Pratchett, a really famous author. It's 45 books, 15,000 pages of material to keep me busy for that 6-month transition from place to place. Oh, and the 6 months back. I'll probably get some of that on audiobook as well because I like to listen to things like that. But definitely bring your computer. I mean, I imagine NASA is going to give me one. Like I said, the internet's probably not going to be all that useful, lag times and all that sort of thing. But, I could bring Minecraft. I'd build a really cool city in Minecraft. Maybe try to build a Martian complex or something like that. I think that'd be pretty interesting. And I definitely need to bring a couple toys. I'm going to be on the flight from Earth to Mars. You're going to be in 0G. There's not going to be any gravity because you're just floating along in a spaceship. So I'm going to bring a yo-yo and a gyroscope. I mean, who wouldn't want to play with a yo-yo while they're floating in 0G out in space? And then I think the last thing I definitely bring, Reese's Pieces. I love Reese's Pieces. Can't go anywhere without them. I don't know. So that's my list. You guys should think about what you want to bring and please share it with me. But the last thing I actually want to talk about is somewhat seriously. People around the world, and especially in the United States, are working really hard to make these sorts of trips possible. And there's 2 really big areas that people work on. There's science, and I do science. I study Mars's atmosphere, and I try to understand how changes in the sun, what I call solar variability, affects Mars's atmosphere. For example, I sit around and I work on a computer a lot, and I try to make pretty pictures. All right, so I got an example of like a picture I made just the other day. This is basically Mars's atmosphere as it responds to a dust storm. So there's dust that comes and goes. You may have heard in the news recently that Mars just had a big dust storm. The dust has an effect on the atmosphere, the temperature and density and that sort of thing. So I study that sort of thing. But in addition to doing science, and there are many, many scientists trying to answer many, many, many different questions, there are a lot of engineers trying to solve these problems that make it difficult to get to Mars or to live on Mars or to do things that we want to be able to do on different planets. NASA has launched a bunch of missions over the past few years, many of them to Mars, but also to other places. For example, NASA launched a few years ago the Dawn mission, which has been orbiting the asteroid Ceres for the past several years, doing lots of interesting science. The engineering behind that is incredible. And if you get a chance to go online and look at NASA's website on just the orbital mechanics involved with getting the Juno spacecraft out to that asteroid, it's just really interesting. Just a couple of days ago, the Japan Space Agency, their satellite Hayabusa 2 landed or let go of a couple rovers that landed on a small asteroid called Ryugu, if I could say that right. Just think about that, like 2 small rovers that landed on this asteroid millions of miles away from Earth, which is just incredible. NASA's got an orbiter around Jupiter right now, Juno, that's studying the storms and the density and the composition of Jupiter and trying to learn all sorts of interesting things about the history of our solar system. There are a million questions that people are trying to answer throughout our solar system. Where did the water go on Mars? What are the origins of our solar system? How did water get to Earth? How did liquid water get to Earth? Where did the elements for life come from when Earth was forming? How did that work? And there's even more questions being asked about planets beyond our solar system. We're finding new planets every single day. And there's evidence now that every star that we see in the sky on average has 2 to 5 planets orbiting it. There's billions and trillions of planets out there waiting to be discovered, waiting to be researched. And we're just getting to the point now where we can understand, we can start to look at those planets in some detail, start to look at the atmospheres in some detail, and it's opening up a whole new world of possible things to study and new things to learn. So I just think it's a really interesting time to be involved in space and planets and science and engineering to make all this stuff happen. So that's what I wanted to talk to you about. I'm really happy to answer any questions either now or if you track me down at Eastern Michigan University via email or give me a call or stop by. I'm happy to talk. But thank you again for having me.
All right. Much thanks to for us out with this. We really, really appreciate it. I'm going to open up the floor to questions. I see we have a couple live viewers, so I'm just going to have you guys comment on anything in the chat. You will see on your YouTube screens. We'll wait for maybe a minute or two. And if you have any further pressing questions, just shoot an email to me or, like Dr. Pawlowski said, to him directly. So for any questions, please email me, like I said, or Dr. Pawlowski. Our emails, I'll post those on social media and in the description of this YouTube video. Once again, thank you all of you for thank you, Dr. Pawlowski, for coming in. And a big welcome to Emma, the newest intern. See you next month. We're going to have somebody from Northern Michigan University talking about transportation research. So that should be very interesting. But for now, goodbye and watch.